You are standing in the Egyptian desert 4,500 years ago. It is noon. The sand beneath your bare feet is hot enough to blister skin in under a minute. There is no shade for as far as you can see. You have no water bottle, no sunscreen, no air conditioning. And yet somehow an entire civilization did not just survive here. It thrived. Summer highs in Upper Egypt regularly cross 40 degrees Celsius. Human skin begins to suffer real thermal damage at prolonged, direct exposure past that threshold. Egypt sits inside one of the harshest climate zones on the planet, part of the same arid belt as the Sahara, with almost no rainfall. So how did they actually do it? The answer isn't one clever trick. It's a stack of small, overlapping engineering decisions. The vast majority of ancient Egyptian homes were made of mudbrick. That material choice wasn't about cost or convenience. Mud is a genuinely poor conductor of heat. As long as the house was kept closed up during the hottest part of the day, the thick walls simply refused to let the heat in quickly. Ancient Egyptian engineers did something genuinely elegant. They invented a device now called the malkaf, a windcatcher. Moving air passing over the top of the structure creates a pressure difference that pulls hot, stale air up and out from the lower rooms at the same time. The malkaf rarely worked alone. Builders paired it with a mashrabia, a carved wooden lattice screen fitted over windows and balconies. Egyptian builders paired the windcatcher with another trick, wetting reed mats and hanging them over windows and doorways. Interior temperatures in well-designed structures could be kept close to a stable 22 degrees Celsius year-round without a single moving mechanical part. A shaded central courtyard let residents carry out heat-generating daily tasks outdoors, away from the rooms where people actually slept and rested. Many households used flat rooftops as sleeping quarters during the hottest stretches of summer. Linen became by far the dominant textile across every social class in ancient Egypt. White linen bounces sunlight away from the body instead of trapping it. This wasn't fashion minimalism. And then there's the detail almost everyone gets wrong: the eye makeup. Kohl was worn by Egyptians of every social class, men and women, pharaohs and farmers alike. The dark pigment absorbed and scattered sunlight around the eyes, cutting down glare, roughly the same principle modern athletes use with black grease paint. A 2010 study by French researchers found certain lead-based compounds in the mixture had a measurable antibacterial effect. Excavations at the workers' settlement near Giza, known as Hayt El Ghurab, uncovered large-scale bakeries and breweries capable of feeding thousands. Beer brewed on site in massive quantities wasn't a luxury indulgence. It was a core source of both hydration and calories. At Deir el Medina, workers followed a structured schedule. 8 days of work split into 2 4-hour shifts with a break at midday. The village had no reliable water source of its own. Water had to be hauled in daily from the Nile by dedicated carriers. When food and pay shipments were delayed, the workers staged what's now considered the earliest recorded labor strike in human history. A room fitted with both a windcatcher pulling air down from above and a mashrabia filtering that air at eye level created a genuine cross-ventilation system. Settlement location was its own form of climate engineering. Ancient Egyptian towns were built almost exclusively along the narrow, fertile band beside the Nile. Evaporation off the Nile's surface pulled ambient heat out of the immediate air, the same way the wet reed mats did, just across an entire river valley. Move even a short distance away from that band, and daily temperature swings became sharper. Survival correspondingly harder. None of it required understanding thermodynamics, fluid dynamics, or germ theory. It only required paying close attention to what kept people alive. The materials were local. The physics was consistent. The only variable was how long it took someone to notice what worked. Tonight, if it's hot where you are, you might reach for air conditioning without thinking twice. But the next time you crack a window to catch a breeze, you're using a version of the exact same logic that kept an entire civilization alive, just with a compressor doing the work a mud brick wall and a north wind used to do on their own.